Okay, so today we're going to look at the chain rule. So we've already seen how to determine the derivative of a polynomial function, as well as those that contain radicals, functions with variable in the denominator. We looked at the product rule, quotient rule. So let's just refresh our mind. We want to find the derivative of the function y equals -4 over square root of x cubed plus x squared minus 78. So first I'm going to rewrite that with a negative exponent and a rational exponent. So we're going to have -4x to the -3 over 2 plus x squared minus 78. Right, so now we can take the derivative of that using our power rule. So my y prime, my derivative of y, is going to be positive 12 over 2, so 6x to the -5 over 2 plus 2x. And then we can write that with our now positive radical. And we get 6 over square root of x to the 5 plus 2x. Right. So there's our derivatives that we've looked at so far. Right, but as we were looking at yesterday, looking at those composite functions, right, it's a bit more complicated of a function to find the derivative of. So first, let's take a look at if I'm given f of g of x, and I want to determine the functions f and g. So if I have h of x being 3x minus 5 all cubed, and I want to find my f and g, well, in this case, f is my outside function, so my f of x would be x cubed. G is that inside function, so my g of x is 3x minus 5. Right, so for p of x, my outside function is that square root, and my inside function is my 4x plus 11. Right, for y there, my outside function, my f of x, would be 1 over x. And my inside function would be the x minus 3x cubed. Right, so it's remembering our composite functions that we took a look at last lesson. Okay, let's also refresh our mind a little bit about our product rule. So if I want to find the derivative of f of x using the product rule, right, we're remembering that my f of x, right, is 3x minus 5 all cubed. Okay, well that looks like 3x minus 5 times 3x minus 5 times 3x minus 5. Right, we can now use our product rule, right? Product of two things, so maybe you want to look at the first two as my first, that last one as my second. So when I'm taking the derivative, second d first plus first d second. And when I take the derivative of the first, it's going to also involve using the product rule. So my derivative f of x, all right, so second d first, right, and when I take the derivative of the first, I got to use the product rule again. So within that first, I have got second d first plus first d second. Okay, so there's my second d first of my entire function, plus first d second. All right, so let's just simplify that a bit there. Okay, so simplify that a little bit. Simplify that a little more. Alright, so I get a nice answer of 9 times 3x minus 5 squared. Okay, so keep that answer in mind, keep that answer in the back of your head there, and we'll see that come back into play a little later. So I want to determine each of the following. These are all taking the derivative, remembering that derivative notation that we had kind of looked at the start of the unit. Right? So I've got the d over dx, right? That's taking the derivative with respect to x. Okay, so I'm taking the derivative with respect to x. All right, so if I'm looking at the derivative for the first one, so I'm looking at the derivative of x to the 5 with respect to x. Right, so that's just taking the derivative of x to the 5, as we have been doing. Right, so I'm looking at, then my answer would be, using my power rule, 5x to the 4. Okay, derivative of y cubed with respect to y. Right, so all of our derivatives we've been using x, y has been the function. Well, in this case, just take the derivative of the expression y cubed with respect to y. So I'm still just using that power rule, which would give me 3y squared. Okay, so derivative delta 2x over x6 with respect to delta. Okay, so again, same idea. It's telling me the function I'm taking the derivative of and with respect to what variable. So using my power rule, 6 delta to the exponent 5. Okay, so derivative of 4x all squared with respect to 4x. Right, so I'm not going to use the product rule in this case. Because I'm taking it with respect to 4x, I can just use my power rule. And I'm going to get 2 times 4x to the exponent 1. Right, I'm taking it with respect to the 4x. Right? Similarly with e, with respect to that 5x plus 3. So I can just use my product rule. And 4 times 5x plus 3 all cubed. Right? F is a bit different. I'm taking the derivative of 4x squared with respect to x. So let's look at a couple ways that we can do that. First off, let's expand that square into the bracket. So really I'm taking the derivative of 16x squared with respect to x. Okay, so that's just going to use my my power rule. And I'm going to get 2 times 16 of 32x. Okay, or what if I go, okay, well, I can take the derivative of 4x squared with respect to 4x, right? But we know we want to have the dx on the bottom. So what if I multiply that by the derivative of 4x with respect to x? You can see how the d4x's would both cancel out if you were. So let's take a look at this derivative then. Well, the derivative of 4x squared with respect to 4x, we already know is 2 times 4x, right? And then if I take the derivative of 4x with respect to x, well, that just leaves me with 4. And if I then multiply 2 times 4 times 4, I get my 32x. So we can notice there that I can break it up a little bit, right? So if we look at the 4x squared, right, that's a composite function, with g of x being the 4x and f of x being x squared. Right, so I can use that power rule, and then I took the derivative of the g of x. So this is actually what my chain rule is. So in my conclusion here, if I'm taking the derivative of composite function, f of g of x with respect to x, I can take that derivative of the composite function with respect to the inside function, g of x, and multiply that by my derivative of g of x with respect to x. Right, so if I have f of x is g of x to the exponent n, then my derivative is going to be n times my g of x to the n minus 1 times that derivative of g of x. Right, so this is part of my chain rule here. So if I have that power, right, if I'm trying to use the power rule, I can use the power rule and then take the derivative of what's inside. Right, so use the power rule as if what's inside stays the same, multiply that by the derivative of what's inside of those brackets. So if we go back to that 3x minus 5 cubed, right? If we remember, we know that derivative, we took it using the power rule, we found it to be 9 times 3x minus 5 squared. So let's use my chain rule here to find my derivative. So I'm going to bring down the exponent as I would in the power rule, keep what's inside the brackets, they're the same, and then multiply by the derivative of what's inside of my brackets there. Multiply the derivative of that g of x, which is just 3, and that simplifies to 9 times 3x minus 5 all squared. Now, I don't know about you, but I would probably say that's a lot easier than using the product rule and actually using the product rule within the product rule as we did on the last page. Okay, so let's go through a bunch of examples, make sure we have an understanding of this, see what's going on. So I've got finding the derivative with respect to the independent variable. Our independent variable in most is going to be x, right? In B it's m, but I'm just finding the derivative with respect to that independent variable. So for the first example there, I've got f of x equaling x squared plus 1 to the exponent 4. So my f prime of x, we're going to use that power rule, so we're going to do 4 times x squared plus 1 to the exponent 3, and then multiply by the derivative of what's inside, which is 2x. So I simplify that, and I get 8x times x squared plus 1 to the exponent 3. Okay, so let's first rewrite g of m with a rational exponent. M squared plus 5m, the exponent of 1/2. Okay, so now I can take my derivative, g prime of m, so use my power rule. So 1/2 times m squared plus 5m to the negative 1/2, and I'm going to multiply that by the derivative of what's inside the brackets, so that gets me to 2m plus 5. So then if we clean that up a little bit, my derivative is 2m plus 5 all over 2 times the square root of m squared plus 5m. And we're not going to worry about rationalizing. Awesome. Okay, so b equals the square root of 1 plus a minus 3 all squared. So let's again just rewrite with a rational exponent. Oops. Okay, so b equals, so we got 1 plus a minus 3 squared to the 1/2. There we go. Okay, so now I take my derivative. So my b prime is 1/2 times 1 plus a minus 3 squared to the negative 1/2. Okay, so now I'm going to take the derivative of the 1 plus a minus 3 to the 1/2. So I'm going to multiply that. So that means my 1 derivative of 1 is 0, so I'm looking at the a minus 3 squared. So if I'm doing that, I'm going to have 2 times a minus 3, and then that's got to get multiplied by 1, right? Because it's using that chain rule there. Bring the 2 down, multiply by what's inside the brackets. The derivative of inside the brackets, derivative of a minus 3 is 1. Okay, and then we tidy up a little bit. So what do we got there? I think my 2's cancel out. Okay, so I've got a minus 3 all over the square root of 1 plus a minus 3 squared. All right, d, the derivative. Alrighty, just gonna do this. There we go. So my y prime. Okay, so take that power rule. 3x squared plus minus 1 to the squared multiplied by the derivative of the x squared minus 1, which is 2x, plus, using my power rule, 10, 4x minus 3 to the 1, times the derivative of 4x minus 3, which is just 4. Alrighty, and then we can clean up a little bit. Then we got 6 squared minus 1 squared plus 40. Alright, and I can factor out a 2 here. Oh, I think I dropped my x up there. Here we go. So 2 times 3x times x squared minus 1 squared plus 20 4x minus 3. And we'll call that one done. Righty. Okay, so 3 minus 2x minus, in brackets, I've got x to the negative 2 plus, or sorry, minus 3x plus 5 to the exponent 4, or all of that's to the exponent 5. Okay, so let's take my derivative because things already have negative exponents there. Alrighty, so y prime is equal to negative 2. Okay, so then using the power rule on those square brackets, so I've got minus 5 times x to the negative 2 minus 3x plus 5 to the 4. All of that's now to the exponent 4. Then multiply by the derivative of those square brackets. So that's going to be negative 2x to the negative 3 minus 4 times 3 3x plus 5 to the 3. That 3x plus 5 to the exponent 3 needs to be multiplied by the derivative of the 3x plus 3. Which is just 3. So there you go. I think there's a very minimal simplifying that we can do for this, so I'm just going to leave that as it is. I'm not going to worry about the negative exponents because the question itself had negative exponents, so I can just leave them as negative exponents there. And I'm going to stop that one where it is. And now take a look at my next one there. F of x equals x squared plus 3 to the exponent 4 being multiplied by 4x minus 5 to the exponent 3. So I'm going to take my derivative there. It's a product rule happening. So my f prime of x is my second times the derivative of the first, which will be the 4x squared plus 3 to the exponent 3 times the derivative of x squared plus 3, which is 2x. Okay, second d first plus my first squared plus 3 to the exponent 4 times the derivative of my second, so use that power rule, times the derivative of what's inside of the brackets. And then we simplify things a little bit here. Looking across all of them. Okay, well I can take out a 4, and then between both terms I can take out a 4x minus 5 squared and an x squared plus 3 to the exponent 3. Okay, well that leaves me with 4x minus 5 times 2x and an x squared plus 3 times 3. Okay, so simplifying that, we got I get 8x squared minus 10x plus 3x squared plus 9. So my f prime of x is times 11x squared plus minus 10x. 11x squared minus 10x plus 9. And there's my derivative. Okay, a few more. Again, maybe take a moment, pause, see if you can get through the rest on your own, and then check your answers afterwards. Okay, so we've got 1 over x squared plus 3x minus 8. So because this is a constant, we're going to change it to the power rule rather than doing my quotient rule. It's just a little bit easier. Okay, so it makes it a little bit easier for us, so I'm going to rewrite this then as y to the x squared plus 3x minus 8 to the negative 1. Now I can use that power rule. So y prime. So negative x squared plus 3x minus 8. Now to the negative 2. And a 9 to multiply by the derivative of what's inside of my brackets, which is 2x plus 3. And that gives me then as my y prime is negative of 2x plus 3 all over my x squared plus 3x minus 8 squared. Right, so that's a lot easier than trying to use the quotient rule of bottom d top minus top d bottom, because my top is just a constant. Anytime I'm taking the derivative of that top, it's actually just 0. So if you think about it, if I do bottom d top, that's just going to be 0 minus top times the derivative of the bottom. So that gets me my minus derivative of the bottom, which was my 2x plus 3. And so it does work, but it makes it a little simpler to change to the power rule. So I'm going to do the same idea here with h, because it is a constant on top. I'm going to have 2 times x cubed plus 1 to the negative 5, and then use that power rule to take my derivative. So negative 10 times x cubed plus 1 to the negative 6 times the derivative of x cubed plus 1, which is 3x squared. And then make that nice and simple looking. I get negative 30x squared over x cubed plus 1 to the negative 6. Oops, sorry, plus 1 to the 6. There we go. Excellent. Okay, again, got a nice constant on top, so let's change this to a negative exponent. So y is equal to 8 times x squared minus 3 to the negative 1/2. Use my power rule, so I get y prime. So I get negative 4 x squared minus 3 to the negative 3/2 times the derivative of x squared minus 3, which is 2x. So I get y prime is equal to negative 8x over the square root of x squared minus 3 cubed. Awesome, and the last one here, so because I do have that variable, I'm going to leave it as a quotient rule. I could change it, but then I still wouldn't be using the product or the power rule, I'd be using the product rule. So let's just leave it as the quotient rule. But first I'm going to write it as a rational exponent in the bottom there. So get x over okay. So now if I take my derivative of g of x, so I don't run into it, derivative of g of x, so I've got bottom times the derivative of the top minus the top times the derivative of the bottom, which is 1/2. Right, so I got to use my power rule. I get 3x plus 2 to the negative 1/2, and multiplied by the derivative of 3x plus 2, which is just 3. bottom d top minus top d bottom, all over the bottom squared. Okay, so let's simplify that. I'm going to factor out on my top there a 3x plus 2 to the negative 1/2. Okay, so that's going to leave me with a 3x plus 2. And then a minus 3/2 x. All over a 3x plus 2. Okay, so now that 3x plus 2, the negative 1/2, can go join it on the bottom. And I'm going to get 3x plus 2 minus 3 over 2x over 3x plus 2 to the 3/2. And that's going to then give me what do we got? 3x minus 3/2 x, so that leaves me with 3/2 x plus 2 over the square root of 3x plus 2 cubed. Awesome. So if you wanted to get rid of that fraction with the x, we could also multiply that 2 by the same denominator and bring that denominator down. So if I wanted to, I could get that being 3x plus 4. So I multiplied the 2 by 2 to bring the 2 into the denominator here. Okay, so that's just another way that you can write it. Okay, so hopefully that wasn't too bad. You'll have lots of time to practice. There's some practice on 158, right, taking a look at numbers 1 to 4. Right, if you have any questions, concerns, misunderstandings, please send me a message, put it in the chat, send me an email, and I'll get back to you as soon as I can. Take care.